makes sense, right?
Yeah, absolutely. I do think too, if we, mental health is, we are learning more and more and more about the way that mental health impacts physical health outcomes. And so, it's really hard to get mental health research funded. I'm one of 17 psychologists at Mott that are doing research like this. And so, there is just a lot of great work being done across diabetes and sickle cell and general pediatrics. And, but I think the more that we think about how mood and anxiety and our emotional well-being impacts physical health, we're going to be able to prevent a lot of adult diseases.
Awesome. Well, thank you for your time, and have a great rest of your day. And I hope the weather clears up.
Thank you for all of your support. And congratulations on a Hall of Fame year.
Thank you. Go Blue.
Go Blue.
Okay, now before we get to our next researcher, we are going to introduce Kristen Finn, who is our matching donor for Giving Blueday. We're going to show you a short video. Stay tuned.
So I'm a proud U of M alum. I went to Michigan for undergrad and studied naval architecture and marine engineering, and then stayed around for another year to get my master's. And then when my now 13, almost 14-year-old was 4, she said, I want a Princess Castle cake. And I was like, well, yeah, I can do this. I can do a little 2D. Sure, let's pull together a Princess Castle cake. But that was where it all started, was this Princess Castle cake. And we've come a long way from Princess Castle cakes. It just became a fun passion project, right, between engineering how the cakes stay stable or how to problem solve. Really, that was the part of caking, as I call it, that I loved the most, was the problem solving. Right, at the end of the day, you've got this fun masterpiece that some kid is so excited to celebrate their birthday. And so I've made a number. I couldn't even tell you now how many, but it certainly picked up in the last 2 years. And I've always been a little bit sheepish. I've never really charged anybody for them, but I was like, I will make your cake in exchange for a donation to the Woodson Fund. We've been making cakes basically since the pandemic started, and even before, for the Woodson Fund. And so I'm really excited to be the matching partner based on all of those cakes made. So probably 150 cakes went into this matching gift that I'm hoping will inspire other people to also donate to the Woodson Fund on Giving Blueday. The why donate is always a good question, because you want to know, everyone wants to know that their money is being used for good. Research is hope, right? And at the end of the day, we're all looking for hope right now. And that's what the Woodson Fund does for people. So whether it's $10 or $250, all of that goes to creating research and creating hope.
All right, welcome back, everybody. Thank you, Kristen Finn, for that great video and all that you do for the Charles Woodson Clinical Research Fund. You're helping raise a lot of money, and then you're also giving your own money. So, we certainly appreciate it. And I know that CS Mott appreciates it as well. And I know our next guest, Mr. Owens, Dr. Owens, I know that he appreciates it as well. So everybody, meet Gabe Owens, our next researcher that we'll be talking to. Dr. Owens, how are you doing?
I'm doing good, Charles. Thanks for having me. And again, as you said, thanks to Kristen and everybody supporting all the different efforts that all of us are trying to accomplish at Mott Hospital and through Michigan Medicine in general. And it's just really great to have the opportunity of, sharing with you, where our projects have come from, where it started way back in, I think, 2012. I think we first connected with some donor money that you provided to get our project off and going. And it's great to update you and everybody listening to show how those initial starts through a foundation such as yourself that you started can really launch really important research endeavors that can help children, help adults, and help our medical community.
Yeah, and I think, let's kind of just get right into it, Dr. Owens. I mean, tell everyone what it is that you're doing, what you're working on, and actually how far you have come, with your research.
Absolutely. I think this is I always love telling this story because I think it really sets the stage for, how people think about innovative research and what we do, sort of out of the box thinking. It'll be sort of a play on words, because we're going to talk a little bit about heart in a box with all the out of the box thinking that we're talking about. But I'm a pediatric cardiologist. I do cardiac critical care. I'm exposed to many of the patients that Melissa was just talking about, patients undergoing heart transplant or patients that have very few options. And just like Melissa, a lot of my research interests are stimulated from the patients that we see. And there was a time back in, again, I think it was 2012, myself, Dr. Bob Bartlett, who is a Hall of Famer in clinical medicine and ECMO, just like you are now. Congratulations to the Hall.
Thank you. Thank you.
And my colleague Martin Box were actually at an innovation summit at a hotel here locally in Ann Arbor. And there was a break in the program, and we were outside eating some granola bars and orange juice and having a chat about some future research endeavors. And this was at the time where your initial donation to Mott was just beginning, and there was opportunity for some funding to really support these beginning projects where we don't have enough data to apply for those federal grants that are so high in demand, that we need data and we need experience. We need to see if our creative ideas have legs. Give us a shot. Let's investigate what's going on. And so the three of us were talking, and we were, talking about different technologies that we use clinically. We were talking about the scarce resource of hearts available for our young kids who need a heart transplant, as Melissa was just talking about. And we wanted to see if we can utilize things we've learned in the laboratory to really change the paradigm about how heart transplants are done for kids, how we harvest organs, how we preserve those organs, and how we get the best hearts to the most needy children. Knowing that the pediatric heart transplant waitlist has the highest mortality of kids waiting. About 1 in 5 kids will die waiting for a heart. That's higher than any other transplant list. So we know there's a problem there. It's that gap that Melissa was talking about, right? We identified a clinical gap, and we said, what can we do better? We also know that only about 40% of hearts that are sort of approved for donation actually get utilized. So there's 6 hearts that don't get used for people who need them. Why is that? And there's lots of factors that are involved, but some of them are involved with the constraints of removing an organ from a very compassionate donor and getting that organ to the recipient. We have preservation, sort of biological constraints, and we have time constraints, meaning we only have a short window of a time where, just like in the movies when you see guys running through the airport with an igloo cooler to take that organ across the country and get it to that patient. We have 6 hours of time where the heart is placed in a bucket of ice, and that ice and that coldness is to preserve the integrity of the tissue to the best of our ability. And it takes we have that short window of time to get it to a recipient.
And is that basically what it's been? Is you put the heart in a bucket of ice? It's
been like that for decades. It has been like that for decades. And that means if somebody's down in sunny, warm Florida needing a heart, and there's a perfect heart in cold, gray Michigan, we can't match those people because it takes too much time. The pragmatics are too hard. So we have to regionalize how we do things based on our limitations of keeping hearts safe and ready to be transplanted. And then there's also that aspect of those other hearts that are unutilized, that we would love to be able to find a way to utilize them. So with all this backdrop, we began thinking, can we change how we preserve those hearts and prepare them for transplant? Should we move away from that bucket of ice or that igloo cooler and do something more sophisticated? And so we thought that we could keep the hearts in a more lifelike state, even after being removed from the donor. That we can basically supply the hearts with nutrients and chemicals and blood products to keep the hearts beating and healthy, so that we can prolong how long we can preserve them for, match the best recipient to the donor, and in the future, hopefully do even more creative things to even more sophisticatedly match donor heart to recipient, so rejection's not a problem, and graft or transplanted heart duration is even longer, because transplant's not a cure for pediatric patients. They might need another heart transplant in the future, But if we can extend how long hearts last, that's going to be an attribute to our patients too. So what we really started doing back in 2012, we said, you know what? Let's see if we can keep hearts alive and well outside of the body. Sort of a heart in a box. Take it out of an animal. We're doing animal research right now. And use our technology similar to ECMO, which is, again, was pioneered by Dr. Robert Bartlett here at Michigan, which is basically a fancy heart-lung bypass machine that we usually use on people like myself. If I had critical illness, or some of our patients who have had COVID during this pandemic. We give them this ECMO technology to bypass their heart and lungs and give them their bodies time to heal. Well, we thought, we've learned a lot about ECMO in the last decades. We've done great research projects in the lab. Why don't we use that technology to support a heart? Just
before you go on, Dr. Owens, please explain ECMO and what that actually means.
So ECMO stands for extracorporeal membrane oxygenation, and it's a lot of fancy words, but really it's, like I said, it's a heart-lung bypass machine. What it does is it takes the blood our body's already used, so it's deoxygenated. Our organs have sucked out the oxygen, and we take it out and put it through the ECMO circuit. The ECMO circuit does two things. It has its own oxygenator, so it's an artificial lung, which the blood can run through, and we can give that blood oxygen just like our lungs are doing. So if a patient has sick lungs and they can't oxygenate their blood, ECMO can do that for them. We can also take that blood and push it back into the patient's body and give them an appropriate blood pressure and give all their organs all that oxygenated blood to survive. So if your heart is sick and it's not pumping strong, ECMO can pump for you. So it's a way to do the functioning of your heart and lungs artificially to support everything else, the brain, the liver, the kidneys, so that patients can either recover from surgery, recover from COVID, recover from other clinical conditions, to buy time for the body to heal, keep organs protected, or give us time as clinicians to find other alternative therapies. And it may be a heart transplant, it may be another surgery or things like that.
Wow. You know what percentage of people have to have multiple heart transplants?
Well, for our adult patients, if you're getting transplanted in your further along decades of life, like myself, it may last, the rest of your life, 20 years or so, like that. For children, we do see a time frame of, since if you get transplanted as an infant, you might only keep that heart for 10 to 15, maybe 20 years, which means that if you're getting transplanted as a 1-year-old, you're going to need another heart transplant in the future. So it's not a long-term solution for our pediatric patients. It might be for adults, depending on what decade of life you get it. But for pediatric patients, we know it's an ongoing clinical burden. It's an ongoing psychological burden, as Melissa just talked about. Knowing, early on that somebody's putting a new organ to save your life, but know that you're going to have to go through this trauma again. It's a clinical and a psychological burden for sure.
So now, how far are we along now? As far as keeping these hearts alive longer. Being able to get a heart, from California to New York if you need to. So where are we at with that?
We have, when we first started, we were starting from scratch. We were taking data that we learned from other organs and from what we've learned clinically from how to utilize this ECMO technology and other things. And, our initial goals were trying to parallel what we're able to do with the igloo cooler full of ice. Can we just keep a heart beating and healthy for 6 hours like we see clinically? And, we went through some different trials and tribulations, and that's where this seed money was so important. It gave us that opportunity to experiment, to research, right? I mean, it's research. We have to keep on searching for answers, redo it over and over again. And we got to a point in the first year or so with the support from your foundation that we were very successfully able to keep hearts pumping in a box for 12 hours, looking strong and looking healthy and looking great. And we said, wow, we're onto something here. Not many people have accomplished that goal in many decades of trying to accomplish the same feat. And we wanted to take it further. We were learning exactly about what components we need to give the heart to keep it healthy, and what things we have to remove from the circuit to prevent toxins from accumulating, and gathering more and more data. We extended it from 12 to 24 hours. Then we extended it to 72 hours. And then we're able to keep, and depending on how we make our circuit arrangements, we've had some hearts last as long as 96 hours outside of any body where they're beating strong. And another important transition that we did is we knew it's important to learn how to keep a heart in a box, but that's not our goal, right? We want to get to the point of putting that heart back in a person.
Right.
So we wanted to make sure that our apparatus, our experimental design was protecting hearts so that they could be good candidates to actually be transplanted. So we have done a series of experiments where we've explanted a heart from a large animal model, put it on our apparatus, so the heart in a box, and kept it beating and healthy and smiling and doing all the normal heart things for 24 hours. So longer than really anybody has ever done this type of organ preservation in this fashion. And then we transplanted those hearts back into that animal model, and they worked. They were healthy. They did their job. They weren't requiring ECMO. They were able to make appropriate blood pressure, deliver oxygen appropriately to the organs, and keep that animal healthy and alive for the time frame that we were doing it in. So there were, Dr. Haft was the cardiac surgeon doing these surgeries, and there were fist bumps, there were high fives, all sterile, of course. But lots of excitement that, we just sort of proof of principle that what we're doing on the laboratory bench, really has the legs to get to the clinical realm. And so now we've gone even further, where we're really isolating and understanding that it's not so much a special magic sauce of what we're giving the heart to keep it alive and healthy for hours on end, but it's important that we are removing certain toxins that are being built up just from the normal behavior of the heart muscle. And we have ways of removing those toxins. We're still identifying exactly what they are, but we're able to, with even less sophisticated circuitry, keep these hearts looking very, very healthy. And we're getting excited about getting some of those big federal grants that Melissa discussed to bridge the final gap from what we're doing in the laboratory to getting this happening with patients and accessing those other 6 hearts, taking hearts that maybe are marginal, that we say, you know what, this heart would be a perfect match for little Bobby, but it's not functioning so well in the donor. Well, maybe we can take that heart, put it in our apparatus, and resuscitate it a little bit for a day or so, and show that this heart is healthy. This heart's a good candidate now. And now Bobby can have that organ that he so desperately needs. And so we're rolling.
So what about the logistics of it? Let's say, you have an apparatus in Michigan and somebody needs a heart in California. Is this something where you could pick this apparatus up with the heart, take it to California, or do you need to somehow get that patient from California to Michigan? How does that work?
Yeah, it's great questions. I think it's probably going to be at least twofold, where I think our apparatus would likely be quite transportable. It doesn't have to be that big. It can be pretty, compact in the way that we've continued to customize the circuitry. So we might be able to explant a heart in Michigan, keep it beating in our heart in a box apparatus, and then transport the whole apparatus to the patient. There's also some other opportunities to centralize the preservation of organs into larger centers where we could still utilize a little bit of the ice and the cold preservation to deliver that heart to a central facility that then could do various spokes, get all across the country. Those are actually some of our more recent experiments where we're actually shown that we can take a heart and do the standard freeze and ice, not just for that 6 hours, but for 12 to 24 hours, and then revitalize it on our system. And then by 8 hours being on our system, they're back to normal. So we're excited about even that opportunity of saying, maybe we can use a little bit of cold, a little bit of our technique, and in the end, just open up the door for a lot more organs being utilized.
And so how does, on a personal note, like to make the advances that you've made with what you're doing, how does it make you feel? And then as you're talking to a patient and you're kind of, if you're, conveying the things that you're going to be able to do with this new apparatus, kind of giving people that hope, how are those conversations with the patients once you tell them about how good you feel about where you guys are.
Yeah, I mean, myself personally, it's really exciting stuff. I've had a lot of research endeavors over the years through, even starting as probably even in high school, college. But this is some of the most rewarding experiences because there's such a direct patient connection where we can really see that we can make a difference in the paradigm of how we perform heart transplants for kids. And certainly we're a little bit away from, operationalizing it clinically, but there are those families and those patients that you do end up having conversations in the ICU or in cardiology clinic where they might be interested in some of the research we're doing, and some people might be even interested in making a donation to help that research if they think their son or daughter might be heading down a road of transplant in the future. And when we do share some of these things, it's it's like, wow, that's what you're doing.
Right.
And
Exactly.
And you get excited, and they get excited about thinking that one, that their providers here at Michigan Medicine are not just walking into a clinic room, doing their exam and writing a prescription, but we're all trying to be the leading edge of medicine and trying to change the frontier. And to hear that their physicians and their nurses and all the other providers are doing all these things, gives them that even more confidence that they're at the right place for their kiddo. And to think that, man, my kid might need a transplant because he's, a single ventricle patient who's going down this complicated surgical pathway where we know that when they're in their second or third decade of life, they might need a transplant. And here's my doctor researching this stuff to see if we can optimize that in the future. It's powerful. It's what keeps us going. We hate that money has to keep us going too, but we need those funds. And I think it's a great story about how it really just how you really, your foundation stimulated this work. And, as to Melissa's point, we've now through some other great donors and philanthropists, the Frankel family and others have continued this research and made great strides, and can't thank you and others enough to give us the chance. And now we've got NIH grants submitted, and hopefully we'll get good scores and, multi-million-dollar grants out there waiting to continue this stuff. And yeah, it gives you goosebumps sometimes.
Good. Well, I know you're going to get good scores, man. And I know you'll get the, the funds that you need to continue your great work. But I just want to say thank you, for taking the time out, man, and sitting down with me again and discussing all of the great work. And hey, I hope to see you in person soon.
Hey, I really appreciate the opportunity. I remember the day in the field house when we were doing some other videos, and I was showing you some of the videos of the Heart in a Box.
Oh man.
Some of my favorite memories of sharing research with somebody who's been so instrumental in helping that research launch. So I really appreciate you, doing everything that you do to really help us at Michigan Medicine, and, and all over. It's really an attribute to yourself and the people that you work with. So thank you so much.
Thank you. Well, you guys heard it all, man. You heard from Dr. Owens, Dr. Cousino about the great work that they're doing at C.S. Mott Children's Hospital. And then you got a great understanding of what your dollars do and what they're needed for. All of the great work that they're doing and currently working on needs you. And you guys have gotten us to this point, and we know you're going to continue to get us over the hump with all of that we're trying to do for pediatrics, and then just people in general. I mean, we're trying to help all citizens. This is not just about one group. So you guys are so important to us. I hope you guys will give. Any amount helps. $1, $5, $10, whatever it may be. Giving Blueday is about everyone. So we thank you guys. Links to donate will be in the description. Somewhere on this page, you'll be able to see it. You'll be able to click on it, and you'll be able to donate. Whatever you give, again, is much appreciated. So thank you. Thank you, Dr. Owens. Thank you, Dr. Cousino, and all of you watching today. We love you. Go Blue.
Thank you. Go Blue, give Blue.